Okay, today we are going to talk about the number E. I believe I've had this definition of E on the board at some point before. And we're going to talk about how it is used for continuous compound interest. That's the definition of E. So we're going to keep that in our back mind. It's 1 plus 1 over infinity. So getting to be something just barely greater than 1, but taken to the infinite power. And that's going to approximately equal 2.718. I don't remember any decimals after that. You can use a calculator if you want. Everybody with a scientific or graphing calculator of any sort should have an E button, or more likely an E to the X button. The reason it's E to the X is because E is the natural base of an exponential function. Why it is the natural base is something that will be left for later. It works really, really well once you get to calculus. So you're going to see it. It's going to come up in this nice, perfectly continuously compounded interest formula. You'll use it for other things, and you might go, why am I not just using some other number? And this year in Algebra 2 and next year in pre-calc, there isn't a great answer. But once you get to calculus, we're trying to introduce you to this idea of E before we're teaching it in calculus. So we're not having to teach the number E, just having to teach how to use it in calculus. So hopefully somewhere along the line, you've seen this formula for compound interest. And hopefully you know that compound interest is interest that I am getting on all the money in my account. So if I deposit $10,000 in an account, that's P, that's called my principal. My interest rate, say it's 5%, is going to be the decimal equivalent to 5%, or 0.05. So I'm going to write this in here. 10,000, 1 plus 5%, the decimal equivalent is 5.05. Now 5% of 10,000 is $500. So that would mean I would get $500 interest every year. But with compound interest, after the first year, I get $5,000 or $500. So I've got $10,500. Now I'm multiplying that by my 1.05. The reason it's 1.05, so here what I did to get my amount of interest, 10,000 times 1, that's how much money I had, plus the interest I made, 10,000 times 0.05. So here I'm factoring out the 10,000, and I get the 1 plus 0.05. Now, here I don't know what this value is, but it's nice if I can get interest on my $500 as well. Instead of having $11,000, I now have 11,025. My third year, if I just again added 500, I'd get 11,500. Or if I do compound interest, I get my total money, which is 11,576.3. Now I've got an extra, instead of 11,500, I've got an extra $76.3. Okay. Well, so this works out in the formula. Let's say I want this to be after 20 years. I don't really want to have to do this every time, but I'm just multiplying by 1.05 each time, so I can do that as an exponential function to the 20th. If I were doing simple interest, $500 a year for 20 years would be $10,000, giving me a total of $20,000. Doing my compound interest, I get 26,533. I've grown quite a bit. I've grown an extra $6,500. I definitely like my compound interest. Now, that's great, but do you really want your interest to only grow once a year? Well, if you're talking about a bank account, how much is in your bank account probably changes every month. So could I get my interest rate to grow monthly? Well, they're not going to give you 5% every month. You probably won't get 5% every year on a bank account, but you might be able to on some sort of an investment account. So what if I could get this? Now, this is assuming I just start with the same amount. It gets much more complicated if we're adding money every month or adding or subtracting. But what they do is you take your rate and you divide it by the number of times you're compounding. If I'm doing that per monthly, that means I'm doing it 12 times per year. So I divide my rate by 12, but then my exponent becomes the number of times I've done my interest, or my number of times per year times the years. So let's take my same example and let's do the 20. We'll do it once per month. Monthly is 12 times per year. Now I am going to enter that straight as that is into my calculator. I'm going to take 10,000 times parentheses 1 plus 0.05 divided by 12. I'm going to hit my exponent key or my caret, whatever gets me to the exponent. You may need parentheses around the 12 times 20. If it doesn't actually move it to an exponent location, if your calculator is writing it out like this, then I do need to do the 12 times 20. If it puts it in a location like the exponent, to get out of the exponent, I use the right arrow, but I do not need to have parentheses around it then. If you're not sure, it never hurts to put parentheses. Let's make that 20 a little nicer here. Now all of a sudden I've got 27,126.4. Okay. I like that better than my 26,533. I've got like an extra $500 just by compounding it monthly. Okay. Let's fix my other 20 here too. So compounding it monthly was helpful. What if I do it daily? Well, daily, there's 365 days in a year. So instead of 12, I do 365. And I make sure to change both my ends. It definitely should always be, the more times per year, you better get a number that's greater. So again, I'm putting it in my calculator. But it shouldn't be a ton greater. Doesn't get me a lot larger. This one gets me to 27,181. Still, I'll take it. It's an extra 50, about $55. I'll take the extra $55. So if daily is even better, I would want, what about minutely? Secondly, continuously. So continuously uses this formula. And it's kind of using E in place of these. And it's moving the R up here. So E being like 1 plus 1 over n to the n, where n goes to infinity. And then the R ends up being part of the exponent on that. So that's how you get this formula. To use it is very simple. 10,000, you do the e to the x button on your calculator. You do the r of 0.05 times time is 20. Make sure not to use the letter E. Okay. The letter E and the number E and the capital E are different things. It's the lowercase e probably has a button that looks like that. Okay. Uppercase E or double E is going to be scientific notation. The letter E just is a letter. Could be used as a variable to store information. This doesn't get us a lot more than daily, but an extra $1.80, I mean, I'd take it. So this is continuous compound interest and the number E, okay?